So to begin with, I would like to start the things with the motivation. Why we are studying these things? So we know that the practically available fuels at this point of time for purposes of rocket motor spacecraft or tactical missiles are solid fuels and liquid fuels. But these two comes with a different packages of drawbacks also. For solid fuels per se, we have drawbacks of reignitability and thrust controls. There may be a possibility of fractures or voids present that during the high temperature operations. Throttle control is also one of the main issues, and also the key concern is of manufacturing. So defect free propellant grain is very difficult to manufacture, and also cost it also has a very higher cost. Similarly, there are few drawbacks with liquid fuels also, that their storage is of main concern, and spillage can always lead to certain issues uh, as far as humans are concerned, it can lead to poisoning also, because there are many components which are present, which are hazardous for during application. Particle sedimentation can cause explosion due to choking of various thrusters, and as I have already mentioned about the reactivity and toxicity associated with the liquid fuels. So why we are using the gel fuels? Because first of all, gel fuel is a combination of solid fuels and liquid fuels. So the advantages of both the fuels can be incorporated, and they can be conveniently stored. Moreover, the shear thinning property. Why I am mentioning about the shear thinning property is because whenever these gel fuels are subjected to combustion in the combustion chamber, they are sprayed, and during that spray, they are subjected to dynamic shear stresses, and therefore the gel, which is a more of a kind of a semi-solid fuel, it gets converted into a liquid. So during the operation, we can incorporate both the properties of solid and liquid fuels. Moreover, stable suspension of energetic nano additives. In order to increase the performance, certain nano additives can also be added, like nano-sized metal particles like aluminium or boron can be added in order to enhance the flames combustion, and in order to get more power out of the fuel. So background. Uh, so far as the fuels are concerned, which are related to aerospace applications, uh, there are disruptions are obtained during the droplets. So the disruption modes which have been observed are puffing and micro explosions, which are mainly concerned with diesel or ethanol based liquid droplets. Mind this, in this case there are no other elements are present, only diesel or fuel ethanol droplet is concerned. Continuous atomization is obtained when ethanol and certain additives are added, like ethanol or slurry based fuels or fuel substitutes or cold water mixtures. So their combustion is a different scenario, and my current study is concerned with gel fuels. So there are inorganic gellants and organic gellants are added, and their mode of combustion involves jetting. Jettings are like small jets are produced during the combustion cycle. The challenge. The combustion behavior of gel and droplet based hydrocarbon fuel is largely unexplored, and there are a lot of ambiguities associated during its studies, and therefore a proper understanding is yet to be established. So there are two things that are needed to be studied in during my work. First, how the flames are get affected during the combustion, and within the flame, how the droplets of fuel which are undergoing the combustion process, how they are performing, and what's the criteria or the thermophysical mechanisms that are involved during its combustion. So the objectives associated are different stages of combustion, which is related to flame and fuel both. Local behavior, that how at local level how the uh, fuel is burning, and what is its consequences to the flames. And various parameters which is can affect the various parameters which like jetting of the combustion performance, that is also be has to be studied. Now, the literature survey that I have done so far, which included mainly one of the, as you can see on the top of the screen, there are few blue and black images. The blue things that you are seeing right now, it represents the flame, and what I am doing is, as I have already mentioned in the literature, that it has been found that during the burning of gel fuels, there are jets are formed in inside the gel fuels. So these the gels, as you can see in the subsequent images, initially an internal jet is obtained. The jet is of if it is a
Janmeji, you have not given reference to these figures.
sir, reference I have given 1 2 3 at the last.
Okay, yeah, the superscript. All right, fine. Continue.
Yes, sir. So, whatever the jets have been obtained in the order of magnitudes of 0.35 meters per second to zero point 0.8 meters per second, they have different effects on the flame. It has been obtained that if the lower magnitude velocity of jet is obtained, then it usually get confined within the flame. Then if the jet speed is relatively higher, then it can disrupt the flame. And if also the jets can also lead to a pinhole jetting, which can lead to the puncturing of flame. And moreover, if the jets have a higher velocity of very high magnitude, then even it can lead to a fireball, which can lead to a separate flame for a smaller interval of time around the flame. Now, as far as combustion studies were obtained, that a shell is obtained, which is shell is of the gellant material, which is usually methyl cellulose or hydroxypropyl methyl cellulose, within which the fuel is concerned. Fuel is confined, and whenever it is subjected to burning, the fuel, due to their variation in their temperatures, like temperature as in the boiling points, usually it has been found that the gellant material, it is having a higher temperature. Let's say we have methyl cellulose and ethanol combination as a gellant. So ethanol has a boiling point of around 70 degrees Celsius, while methyl cellulose is having a boiling point of around 310 degrees Celsius. So we can easily assume, it can be easily assumed that the ethanol is going to boil earlier in comparison to that of methyl cellulose. And therefore we can see that in the screen, in which you can see a green mass just above 3, that is the shell which is obtained, and it has been obtained during the experimentations. These parameters of varying boilings of the various component had been characterized with the help of a TGA, that is thermogravimetric analysis, in which the mass percentage of the various components with time and temperature were obtained. And it shows that the steps that you can see in black represents the uh, boiling off of various components. For example, ethanol will boil off earlier in comparison to the methyl cellulose. Similarly, this is our proposed test facility that will be made during our experiment. The insert images that you are seeing, like the droplet and the droplet flame, represents the gel droplet, which is before the during the combustion, at the start of ignition. And the droplet flame characteristics, you can see that it has been encircled, that various jets have been observed, and this is subjected to study. And as far as studies are concerned, we are going to find the various angles on which the jets are produced, along with the uh, velocities and their orientation in terms of their flame distortion also. So this is the proposed work plan. As I've already mentioned earlier, that we will be characterizing the flame, and also we will be doing the rheological characterization, so that we can easily gauge how the material, how the gel material will behave during the spray, and also during the combustion processes. So for your references, this is the thing, this is the droplet scale and flame scale projections during a live real time scenario, and how the things are processed, you can see on the images. At flame scale, you can see that there are jetting is taking place. At the center, you can see there is a sudden disruption in flame due to jetting. And at the left, at droplet scale, the shell usually is expanding from inner side of the fuel. And when the temperature increases, the temperature, due to the increase in temperature beneath the surface of the shell, the fuel boils off, and it creates a pressure. And due to the difference in pressure, the energy mode of due to the difference in temperature, the energy gradient is built up, and therefore we are observing a jet, and that is we can see on the flame scale in the right. These are the references that I have used in order to get this